morning. My presentation today deals with the ecological footprint of industrial water in island territories, sustainability versus resilience. First of all, I want to point out that this research is connected to my PhD thesis, and this is the opportunity to share part of its results. The water-energy binomial would have a significant relevance if we put it in relation with carbon emissions generated in the artificial water cycle. Moreover, island territories require to take into account their isolation and vulnerability. Water desalination technology is not itself sustainable. Specifically, the energy consumption associated to water production in regions with high water demand allows us to identify a truthful distribution of some externalities associated to this industry. In particular, water desalination powered by renewable energy sources can lead to provide enough water, reduce emissions, and preserve natural capital. In addition, conventional water depuration can switch to a biological depuration through decentralized constructed wetlands. Thus, resilience is enhanced not only due to carbon footprint reduction, but dissolved water is recycled, raising the regional hydrological balance. And what is more, the use of vegetation in those alternative depuration systems should increase biomass. The scope of this research is the Canary Islands. It is an archipelago located to the northwest of Africa belonging to the Spanish state. The Canary Islands serve as a paradigm of the serious consequences inherent in any island region devoid of conventional energy resources and not connected to continental networks. Therefore, each island has its own generating power plants. In addition, the island's features influence the potential to develop renewable energies coherent with a sustainable model in the region. At the same time, there is a high water stress in the aquifers. In fact, there is marine intrusion in coastal water walls and low level of natural recharge in its hydrological balance. In the first place, I want to describe the Canary Islands' energy supply in 2005. There is extremely high foreign energy dependence, approximately 94%. And in this regard, there is a significant waste of transportation sector for the primary energy demand. Fuel supplies are exclusively available by sea, and thus presents excessive vulnerability to any energy crisis. Secondly, desalination represents 55% of the water supply in the region. As a matter of fact, the Canary Islands produce more than 600,000 cubic meters of water per day by installed capacity. It represents almost 30% of the Spanish supply and 2% world ranging. It is considered as an international benchmark in terms of the number and range of desalination processes installed, despite the small extension of this territory. Reverse osmosis is the leading technology, roughly 77%, and it also represents the largest desalination capacity, about 71%. To contextualize the ecological footprint of desalination in a region, we calculated its whole ecological footprint. The lack of sufficient information at local and regional level has forced me to get information from the Spanish ecological footprint established by the Global Footprint Network, setting up the methodological adaptations for the various types of territories. Precisely, carbon uptake land represents the largest contribution to the regional ecological footprint, grossly 71%. Now, I will focus your attention on the Canary Islands production ecological footprint. Also, the carbon uptake land is the greatest amount, representing 75%. Resource consumption in the Canary Islands and Spain are higher than the world average, but more alarming is the offer of natural resources to support this level of consumption. The available biocapacity in the Canary Islands is below the Spanish one and even lower than the global average. The industrial production of water could be segregated from the regional production carbon footprint. Thus, it allows assessing the impact of various alternative energy scenarios. To have a meaningful approximation of its contribution, we detach the production carbon footprint of two broad sectors, electricity and heat production, nearly 57%, and the transport sector, round about 35%. Seeing that, we will focus on the remaining 8% and the contribution of desalination to it. The constant updating of improvements in the performance of desalination plants is uneven and requires a complementary analysis which is beyond the scope of this work. Two assumptions were made to cover this uncertainty: between 3 and 5 kilowatts-hour per cubic meter of water produced, depending on the inclusion of energy recovery device. As a result, while the average fossil desalination produces 21% of the production carbon footprint at the previous cluster sector, the average wind desalination decreases 40% of it. Due to this implementation, carbon dioxide emissions would be significantly reduced. The Canary Islands only reuses a low 28% of treated water. The remainder is returned to the sea. This unsustainable reality would be a challenging situation to change. Apart from that, conventional depuration uses electricity to accelerate the sewage biological degradation. The table shows the carbon dioxide emissions related to the natural and conventional depuration. Both generate carbon dioxide during organic matter's decomposition. However, natural depuration has the potential to produce oxygen and biomass if biomass is taken into account, and thus not demand fossil fuel at all. It is a fact that constructed wetlands occupy territory. However, they add positive externalities through catalyzing several economic activities around them. In this research, we assess the effects of hybrid constructed wetlands, combining subsuperficial horizontal flow and subsuperficial vertical flow. To a certain extent, the regional climatology is favorable in reducing the ratio of surface per population equivalent, but calculations have been made with the conservative data. As a guesstimate, those hybrid constructed wetlands would be assignable as agricultural land. To a certain extent, up to 60% of this land is abandoned, and that combination would take only 2% of it. Besides, as a general rule, reeds should be the biomass reference. They are considered as one of the most distributed superior plants. The data obtained from the table shows the amount of carbon fixation per year by this plant. The photosynthesis chemical equation and the carbon dioxide synthesis reaction help to convert carbon into carbon dioxide through stoichiometric relations. On the one hand, fuel desalination can contribute almost 23% of the energy production ecological footprint segregated, accepted as the remainder after subtracting the carbon dioxide emissions related to the energy production and transportation. Desalted water's fossil depuration can be estimated as nearly 3% of that fraction. In accordance with these approximations, the whole fossil industrial water production should be approximately 27% of it. On the other hand, wind desalination would reduce roughly 44% of the energy production ecological footprint isolated. Moreover, a biological depuration with constructed wetlands, hybrid constructed wetlands, adds more advantages connected with the reduction of carbon dioxide emissions. About 1.4% attributable to the absence of fossil fuels in spite of nearly 2% due to the unavailable carbon dioxide emissions imputable to the bacterial degradation of sewage. Even though, if we implement reeds as biomass production in those wetlands, the carbon dioxide fixation through the photosynthesis should offset almost 14% of that fraction. In that case, it would have as a consequence the reduction of almost 60% of it. As conclusions, the objective of this study is to estimate the availability of the ecological footprint as a tool for the enhancement of resilience through water management. All insular constraints make the water a difficult issue to analyze regionally. Each island has its own specificities to maximize its natural water resources. Desalination is an option within a myriad of actions for the sake of resilient management in its natural, social and economic reality. Decentralized hybrid constructed wetlands offset water industrial production, enhancing biomass and bringing down carbon dioxide emissions related to conventional depuration. Thanks for your attention. I will be pleased to answer if you have any questions. Anyhow, you can send me an email if you want to get additional information about this research.